In the next two videos, I want to discuss the concept of slope. Now, in this, in part one, I'm going to talk about the definition, which is the rise over run, and I'm going to show some notation that I like to use for it. Then I'm going to talk about the slope of horizontal lines and slopes of vertical lines, and the slope of a diagonal line. And I'm going to show you a few examples on how to find the slopes of those. And then in part two, what I'm going to do is look at specific examples of types of problems. So the slope of parallel lines, collinear points, and the slope of perpendicular lines. So let's get started with part one. Okay, the first thing I wanted to do is to define the slope. Okay, now as I said earlier, the slope is defined as the rise over the run. Okay, so let's say, let's just imagine, for instance, that we had like a ground here or something like that, and it was flat. Okay, and we had a ramp. Okay, if I was going to talk about this ramp, let's say I'll just draw it in brown. Okay, or I'll draw that as green, and I'll make the ramp brown. Okay, if I had the ramp and it went like this, okay, relative to the ground at a low angle, what you'd see is that there is very little rise, okay, so, and a lot of run. Okay, so meaning that the ramp travels very far but goes up very little, which means that this is not sloping very far. Okay, and it kind of makes sense from the equation that if this number is very small and this number is very big, then this number should be very small as well. Okay, on the other hand, if this ramp was like this, what you'd see is it'd be going up quite a bit over a relatively short distance. And what this would mean is that your slope would be very large. Okay, and once again, if you put this very large number in here and a very low number in here, then you're going to get a very large number. Okay, and that's the definition of a slope. Okay, now in mathematics, slope is generally abbreviated with the letter m. Okay, and although most people refer to it as rise over run, a better way of thinking about it is delta y over delta x. Okay, now in math, delta means change in. So how much did the y value change and how much did the x value change in that same interval? Okay, so first thing I want to do is talk about a horizontal line. Okay, so let's say, for instance, I had a horizontal line, and I'll just make it go like this. Oops. Okay. And let's just give some points here. They don't have to be exact for the example. So let's say this is 1, 2, 3, 4, 5, 6. So -6 and 3. Okay, we'll call that point A. And then we'll say point B is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is 9 and 3. Okay, and this is point B. Okay, well, what we can find here is that if we're looking for the slope, okay, so slope is equal to m, okay, which is the change in y over the change in x. Okay, now how much did y change here? Well, the y value went from 3 to 3. So I have ay minus by, okay, and the x values went from ax to bx. Okay, so ay is 3 minus 3, and ax is -6 minus 9. Okay, and we get 0 over -15. And what this is 0. Okay, and this is the same of all slopes of horizontal lines. You'll always find that their slope is 0. Okay, and it makes sense. Basically, there's no slope. Okay, so this never rises. Alright, so that should be pretty straightforward. Okay, let's go back here and we'll talk about a different type of example here. Okay, let's go to the vertical line. Okay, so if I had a vertical line, let's say one going from about here to here, it doesn't really matter if it's exact or not. Okay, and we'll say this is A and this is B. Okay, and it doesn't even really matter about the numbers. Okay, what you'll find is that the slope is equal to change in y over the change in x. Now we're going to have some change in y here, and in this case it's, let's see, ay minus by. Okay, and that's ax minus bx. Okay, so the change in y we'll say is 1, 2, 3, 4, 5, 6, 7. Okay, it's about 7 to 1, 2, 3, 4, 5, 6, let's say 6, minus negative 6. Okay, and that's not really the important part. The important part is what's happening in the denominator position here. Okay, ax we'll say is approximately 4, and bx is approximately 4. And then what we get is 13 over 0, and division by 0 is impossible. So it means basically it's not defined, and that is the slope of any vertical line. Okay, it is not defined. Okay, so we call this undefined. Okay, it's not that it's impossible, it's just not known. There's no way to describe what this is. Okay, and it kind of makes sense because it raises up in an infinite distance over no run. Okay, so okay, let's move on to finding the slope of a diagonal line. Okay, for this one I like to get a little bit better of a graph here, so just need to be a little more diligent. Okay, so let's say for instance I had a line like this. I'm just eyeballing it here. Okay, let's say something like this. Okay, and this point A, and we'll say that A is 1, 2, 3, 4, 5, negative 5. And 1, 2, 3, 4, 5, 6, 7. So negative 7. Okay, and B is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So 5, 5. Okay, now if I wanted to find the slope of this, what I would do is I would just look at the change in y over the change in x. Okay, so I have slope is equal to m, which is equal to the change in y over change in x. And what I'm going to do is I'm going to take ay minus by divided by ax minus bx. Okay, so I'm just finding the difference between them. Now it doesn't really matter which order you put them in, if a comes first or the b's come first. But if the a comes first at the top, then it has to come first at the bottom. Okay, so ay is, let's see, negative 7 minus by, which is 5. Okay, and ax is negative 5 minus bx, which is 5. Okay, and so this gives me negative 12 over negative 10, okay, which is 6/5. Okay, and I'm just going to leave it like that. I'm not going to put it into a decimal value. Okay, so a common thing that people ask me is, well, why doesn't it matter? And I'll demonstrate why it doesn't matter. Okay, so if I did this in the opposite way, I chose to put b first. Okay, I'd get by minus ay. So these are equal signs. That's a terrible equal sign there. Okay, divided by bx minus ax. And as I said, it doesn't matter so long as if the a's come first on the top, they have to come first on the bottom. B comes first on the top, then it has to come first on the bottom as well. Okay, so you got by is 5, ay is minus negative 7. Okay, and ax is negative 5 minus bx, which is, oh sorry, bx. Sorry, and I just made the mistake I told you not to do. Bx is 5 and ax is negative 5, so minus negative 5. and that is 12 over 10. And you see that the negatives here cancel each other out in this case. Okay, and I'd end up with 6/5 again. So it doesn't matter what order I do them in, as long as I'm consistent. Okay, now one last note I want to leave off with is that it doesn't matter which way the line is really going. Okay, so if the line is going in this direction, you do it exactly the same way. However, what you would expect in this case is that this would be a negative slope. Okay, so lines that are ascending from left to right, so they are going up like this, those are positive slopes. Ones that are going down like this are negative slopes. Okay, and if you just follow the formula and you look at the y value, the change in y over the change in x, you should get a negative slope. Okay, so if you don't get one for the orange line, then that would be a problem and you probably did something wrong. If you didn't get a positive slope for the green line, then that would be a problem as well, and you should check your work. Anyways, that's a very brief introduction to slope. And in the next part, what we're going to do is talk about a couple of different applications of slope.